Okay, we're reviewing chapter 6 next, towards algebra. And the first topic in this chapter is evaluating expressions. And that just means replacing variables by the numbers that you're told they're equal to. Alright, and that's, we'll need exactly the same steps, this evaluating idea, when we're using formulas and functions, and so it's the same thing. Example 1, so here's a basic example. So here's an algebraic expression. Evaluate this when x is -4. Alright, so x is a variable. It could represent any number. But here we're told that it's equal to -4. So we're just going to substitute. So every x gets replaced with a -4. And it's a good idea to use parentheses. I've noticed most of you not using parentheses in the homework, but it's a good idea. Alright, so here we've done the substitution. And now we just have numbers, so now we need our order of operations. Do things in parentheses first, then take care of exponents, then multiplication and division. They have the same priority, go left to right, and then addition and subtraction come last, left to right. Okay, we have parentheses, but nothing to do in them. So the first thing is take care of this exponent. So -4 to the power 2. And that's -4 times -4, that's 16. Okay, next take care of the multiplication. So 3 times 16 is 48. What's left? Well, we still have a subtraction and an addition. Okay, so the subtraction's on the left, so do that first. 48 minus -4. Yeah, we did that over here, so remember, subtracting a number is the same as adding its opposite. The opposite of -4 is 4. So here we're getting 52, and then the last A addition, 53. So the answer is 53. So this whole thing, this expression evaluated to 53 when x is -4. If you put in a different number for x, you'll get a different answer. Okay, so the places to avoid mistakes. Yeah, use parentheses when you're substituting to keep everything straight. And also, so it's not 3 times -4, so we're not squaring -12. This, whatever number here is, whatever this x is, it's getting squared first, and then it's multiplied by 3. So exponents before multiplication. And you should only be doing addition and subtraction at the end of the problem. Example 2. So now we have two variables and a fraction. Evaluate a squared minus ab plus b when a is 1/2 and b is 3. Okay, so just being careful here. So this a squared means whatever a is, it's going to get squared minus ab. So this is a times b, and then plus another b. And so substituting looks like this. And so the a's get replaced by 1/2. B's turn into 3's in parentheses. Let's take care of that exponent first. The e. So what is 1/2 squared? Well, it's just 1/2 times 1/2. Multiply straight across, that's 1/4. So this piece, so doing this first, we get 1/4, and then minus 1/2 times 3. How do you multiply a fraction by a whole number? Well, just put the whole number over 1. So it's 1/2 times 3/1, and multiply straight across. That's 3/2. Alright, so we get to here. Yeah, now we're just subtracting and adding fractions. Put them over the same denominator, so put them over 4. So multiply this with 2, so that's minus 6/4. And multiply this with 4's, so that'll be plus 12/4. Okay, when you're adding and subtracting fractions, you need a common denominator. The least common denominator here is 4. So we're getting 1 minus 6 plus 12. That's 7/4. Yeah, 1 minus 6, that's -5. And -5 plus 12 is 7. Alright, so this whole thing evaluates to 7/4 when a is 1/2 and b is 3. Alright, so again, it's the same steps, substituting, and then use the order of operations to work it out correctly. Example 3. So this is similar. We're just calling the algebraic expression a formula. So use the formula BH/2 for the area of a triangle with base B. So the length of the base is B, the height of the triangle is H. To find the area of a triangle when the base is 60 centimeters and the height is 13 centimeters. Yeah, so this is a small picture. So yeah, the base is 20 centimeters. The vertical height is 13 centimeters. And we're looking for the area. And this very simple formula. So it's just that here B is 20. H is 13, so it's 20 times 13 when you substitute, divided by 2. Yes, so that's 260 on top, divided by 2, 130. Alright, so yes, just a simple substitution. Here we're evaluating this formula when B is 20 and H is 13. So the number is 130, and don't forget to get the units right. So for area, you need square units. So 130 square inches. No, the units here are centimeters, so 130 square centimeters. Alright, let's do one using a function. So example 4, find f of -10 for the function f of x equals x to the third power minus 9x. Okay, so we're dealing with functions here, and this is a special function notation. So this is f of x and functions, yeah, they're just given by formulas. So f is the name of the function, x is what goes in, and then what comes out is x cubed minus 9x. Alright, so what's going in here is -10, so we're just replacing -10, the x is by -10. So f of -10 is equal to -10 quantity cubed minus 9 times -10. Alright, so yeah, we're just doing the same thing again, just with these fancy functions, function notation. Take care of the exponent first, so -10 times -10 times -10, that's -1000. Then take care of the multiplication. So you could do 9 times -10 is -90, and subtracting -90, that's the same as adding 90. And then we do this addition last. So -1000 plus 90 is -910. So that's the answer. So if the input for this function is -10, then the output is -910. And yeah, just to explain this last addition again, so a good review of adding sign numbers. Yeah, we're adding two numbers here with different signs. So you subtract the smaller absolute value from the larger. So it's 1000 minus 90. And if you do that subtraction, that's 910. And then you use the sign of the number with the bigger absolute value. So that's you use the negative sign. All right, so that's how we got -910. Yeah, the Pythagorean theorem also leads to different formulas. So this is the basic formula. So if you have a right-angled triangle, so a triangle with a 90-degree angle, the short sides on each side of that 90-degree angle called A and B. C is the long side, the hypotenuse. So then the Pythagorean theorem relates these three numbers. It says a squared plus b squared is equal to c squared. And if you take the square root of both sides, you get it in this form. So just c is equal to the square root of a squared plus b squared. Alright, so you use this formula if you're looking for the hypotenuse, if you're looking for the longest side. But you can rearrange this, so subtract b squared from both sides. So solving for a, so a squared is c squared minus b squared. Take the square root of both sides of this, you get a is equal to the square root of c squared minus b squared. Alright, so we have a minus sign in here. So if you're looking for one of the short sides, then use this formula. Use this one when you're looking for the longest side. Alright, example 5. In a right-angled triangle, the hypotenuse is 21, and one of the legs, one of the short sides, is 13. Find the length of the remaining side. Alright, so this, we know the longest side is 21. One of the short sides is 13. We're looking for the other short side, so we're using this formula in the second one. And so C is 21. We could say B is 13, and we're looking for A. So A is the square root of C squared minus B squared. So we need 21 squared minus 13 squared. 21 squared is 441. 13 squared, yeah, I knew that one. That's 169. Subtract. 441 minus 169. Borrowing, that's 272. If I did it right. And that's the answer. So A is the square root of 272. And you're writing out the answer, so that the remaining side, so the side we're looking for, has length the square root of 272. Can we take this square root? Yeah, it's not an even square root. So the square root of 256 is 16. And the square root of 289 is 17, so we're in between those two. So it's, if you use your calculator, you get 16 point something. But this is the best answer here. Just leave it as a square root. Okay, so if you're looking for one of the short sides in a right-angled triangle, use this formula. If you're using the hypotenuse, use this formula with the addition. All right, then the second topic in this chapter is solving linear equations. Alright, so these are the simplest types of equations. The basic example looks like this. 9x plus 14 equals 68. And to solve it, what does solving mean? It means we're looking for what number can we put in for x to get a true equation, to have the left side equal the right side. Okay, so there's some simple steps to solve this. So the first step here is, we want to subtract 14 from both sides. So here we're subtracting 14 from the left side and 14 from the right side. So why are we doing this on both sides? Well, we're assuming that this equation balances. So as long as we're doing the same thing on both sides, it's going to stay balanced, and we're not changing the solutions. Okay, so subtracting 14 gets rid of this 14 on the left. we get the simpler equation 9x is equal to 54. Alright, so the x that works for this is going to work for the original. The second step, we have 9 times x, so we want to do the opposite, so divide both sides by 9 to get 1x. Okay, so dividing here by 9 and dividing on the right by 9. So 1x is equal to 6. And that's the solution we're looking for, so x equals 6. And yeah, you can certainly check that that number works. So yeah, so 9 times 6 is 54. 54 plus 14 is 68. Example 7 is very similar. So this time it's 3x plus 4 equals 2. Subtract 4 from both sides this time. So 3x is equal to 2 minus 4, that's negative 2. And divide both sides by 3. So 1x is equal to negative 2 divided by 3. Negative divided by a positive is negative, so the whole thing is negative 2/3. And the mistakes to avoid here, I mean, subtracting 2 from both sides is not a good first step. Also dividing both sides by 3 is not a good first step. Really the only good first step here is subtract 4 from both sides. You want the x's on one side and the numbers on the other. And again, you could check your answer. So put in negative 2/3 for x. 3 times negative 2/3 is negative 2, and negative 2 plus 4 is 2. Example 8, so a more complicated looking linear equation. 9x plus 1 is equal to 3x minus 4 plus 6. We're still trying to solve it, so what number can we put in for x to get a true equation? So yeah, first we're looking to simplify the equation, and there's an obvious simplification here. So negative 4 plus 6, that's just 2. So we can replace this piece with just 2. Alright, so that's some progress. We see the difference here. So in this example, we have x's on both sides. In the previous examples, there was just x on one side. Okay, so there's an easy step to fix that problem. So here we can just subtract 3x from both sides. Okay, we don't know what x is, but we're allowed to, whatever it is, we can subtract 3x from both sides. Okay, so 3x minus 3x is 0x. 9x minus 3x is 9 minus 3 quantity times x. So that's 6x. Okay, so these linear terms, it's just like saying, yeah, so 9 apples minus 3 apples is 6 apples. 9 of anything minus 3 of the same thing is 6 of those. Alright, and this is a good step, so this cancels the x's on the right, and now we just have x's on the left. And you want just the x's on one side. And now we can continue like before, so now take care of this 1, so subtract 1 from both sides. And we get 6x is equal to 2 minus 1, that's 1. So 6x is equal to 1. Divide both sides by 6 to get x. 1 divided by 6, well, that's just 1 over 6. So x is equal to 1/6. Yeah, I know some people find this confusing, this last step here. Yeah, well, it's, yeah, 6 times some number is equal to 1. Well, yeah, that number has to be 1/6. And by the way, yeah, 1 over 6, isn't that just equal to 6? No, these are two different numbers. Okay, so 1 over 6, it's a small number, much smaller than 6. Alright, so it looks like x equals 1/6 is the solution we're looking for, so the answer was a fraction. And here we're checking that that answer did work. So putting that x equals 1/6 back into the original equation. So if we substitute and then work out each side, so 9x, think of that as 9 over 1 times 1 over 6, so that's 9 over 6. We can cancel 3's, so that's the same as 3 over 2. 3 over 2 plus 1, we need a common denominator, so 3 over 2 plus 2 over 2, that's 5 over 2. And on this side, we got 3 over 6, that's the same as 1 over 2. Yeah, this is the same as 2. So we also get 5 over 2. So yeah, so this answer does work. Alright, so again, the steps here were first look at each side separately and see if you can do any simplification. If you have x's on both sides, then subtract one of those. Yeah, we could have subtracted 9x from both sides. That would have worked too. And then we get it to a basic linear equation. Okay, one more example. 9, solve 3 times x plus 2 in parentheses plus 2x equals negative 2. And so the first thing to do here is to remove these parentheses. So we're going to distribute, so we get 3 times x plus 3 times 2. So that's 3x plus 6. Alright, so this first piece is really simplifies or expands to 3x plus 6. And then we still have 2x plus 2x. On the right, it's equals negative 2. Now the next step here, we have these two linear terms, 3x plus 2x. And so we can combine those into 5x. Alright, so we're simplifying this left side. 3x plus 2x is 5x. And we still have the 6. Alright, so these two extra steps here are this distributing and then combining the linear terms here. So we get 5x plus 6. Alright, so we've just been working on the left side. And now we can continue as before, subtract 6 from both sides. So 5x is equal to negative 8. And divide both sides by 5. So 1x is equal to negative over a positive. The whole thing is negative 8/5. All right, so that's the answer to that one. Yeah, so this is the hardest type of linear equation we look at. All right, that'll do it.